Interfaces. A Systemverilog interface encapsulates the connectivity between different modules which may be design or testbench blocks, and it bundles various input-output ports of modules together. In this session, you will learn why you need to use an interface in your program and how to use. Before learning more about interfaces, let's see why should someone use Systemverilog interfaces in the program. Here are the signals in an AXI write address channel bus. If you are not familiar with AXI protocol, just understand that it is a master-slave protocol, and in this channel, the master will drive all these signals along with this valid, and the slave will drive the ready signal. Assume that in your design, you have 4 different sub-modules which are processing data in this channel. In conventional port-based module modeling, you need to list down all these signals in all 4 modules, and specify their directions as input or output based on the functionality of the module. Thus you will write a lot of redundant code, which is difficult to maintain and comes with more probability of introducing bugs in the design. The same problem will be encountered if the top-level design module has also this bus as ports, and then you need to connect the signals and drive them from the test bench also. Systemverilog provides a new language construct called interface to deal with this problem. An interface is used to bundle a group of wires or signals and to manage their connectivity, synchronization, and optionally, the functionality of the communication between 2 or more blocks. This is an example of defining a simple interface. Interface definition should be within the keywords interface and end interface. The syntax is, the keyword interface, name of the interface, and arguments. Here the argument is only the clock signal. Within the interface, request and grant are 2 variables that are bundled in the interface. Note that they are of type logic. This is how you use the interface within a module. Instead of listing individual signals in the port list of the module, the interface name given. Here, simple_interface is the name of the interface that you have given while it is defined, and intf is its instance within the module named design. Not you can access the individual signals in the interface like intf.clk, intf.request, etc. To pass an interface into a module, you need to create an instance of the interface somewhere above the hierarchy of the module, and pass that interface instance while instantiating the module. Here the design module is instantiated within the testbench module. Before that, the interface named simple_interface is instantiated with name tb_intf, and it is passed as the argument in the design module instantiation. Now once you drive signals in the tb_intf as shown here, those will be driven into the design instance named d1. While instantiating an interface, you need to pass all the arguments in the interface. Typically, only clock and reset signals will be listed as arguments in any interface definition, and all other signals will be declared as internal signals of type logic. This usage will be trivial when you learn mod ports in the next session.